The majority of videos that I see on service mesh are talking about exactly that, which makes sense, right? It's talking about service mesh. But taking out the service mesh name, right? Taking out the Kubernetes name, right? All that, what is it actually? What does it give us? And to be able to answer that question, we got to talk about what a service is, okay? Now, I'm not talking about a Kubernetes service. I'm talking about an actual application service, all right? So let's just say, for example, I have two applications, or at least two parts of my application, okay? So, maybe this is a web app, right? So maybe it's, running Flask or Django or something like that. And then you have, some middleware, okay? My web app, okay, could be a service. My middleware could be a service as well. If you're thinking about just parts of your application stack as a whole, or maybe even sometimes the entire application stack, maybe you're thinking about it from like a monolithic perspective, these are services. Like these can be considered your application services. My Flask app could be considered my application service, okay? So I have these two things and they need to be able to talk to each other, right? Depending on who set up the network, what your network engineers and your network admins put into place, maybe the traffic is encrypted, maybe it's not, maybe, this side of the house is on a separate VLAN than the other. All depends on how it's set up. But in the world of cloud native, what this ultimately looks like is your Kubernetes service, okay? So what your Kubernetes service essentially does is, let's say we take this same example here, right? We have, a Django or a Flask or whatever web app, and then we have some middleware. What ends up happening is, here's our service, but now it is in a Kubernetes service. Okay, so we have this Kubernetes service, and in the realm of Kubernetes, depending on how you're implementing your network, right? Maybe you're using Cilium, maybe you're using Calico. However you're doing it, you have to implement something called a CNI, a Container Network Interface. Okay, now from a Container Network Interface perspective, this works on, that marker is not great. This works on your L3, all 4 layers of your OSI model. Your CNI is how your network is ultimately implemented within your Kubernetes environment, okay? So now I'm not even talking about like the node networks, right? Because you have your nodes, which are, your virtual machines, your EC2 instances, or even bare metal boxes, but you have that host network, right? So let's not even talk about the host network. We're just talking about the internal Kubernetes network. Now, depending on how you're implementing this, again, you could have so many different CNIs here. Maybe you have, Flannel, or even, you have like the AWS CNI and the Azure CNI and all them. Now, depending on how you're implementing them, you could have pod-to-pod communication that is encrypted, but the majority of the time, hopefully, the majority of the time, services, right, parts of your application stack, or people implementing or talking to your application stack, hopefully it's going through a service, okay? Now, if people are coming into the cluster, right, chances are they are going through some type of ingress controller or the Kubernetes gateway API, which you can kind of think about that as like your ingress 2.0, so to speak. Okay, but even taking this piece out for a second, okay, even taking like the traffic that's coming into your cluster to be able to hit your Flask app or your Django app, taking all that out, these services still need to be able to talk to each other. Now, going back to the whole CNI and the whole, implementation of your Kubernetes network, the Kubernetes network is very flat by default. So like, it doesn't matter if, the application stacks are different. It doesn't matter if the application stacks are in a separate namespace, and if there's no like network policies or anything. By default, your Kubernetes network is very flat, which means services can talk to each other, and it's all unencrypted traffic, okay? So, for example, maybe we have some, man-in-the-middle attacks, okay? And that traffic can be intercepted with whatever tool that they're using. So what we need to think about is, okay, I have these services, they're running pieces of my application stack, what can I implement here? And that answer is typically a service mesh, but there are three key reasons, why you may want to implement a service mesh. The first is kind of what we've been talking about. I'm trying to find, I have a bunch of different markers here, but the colors aren't, the colors don't come out all that great, and my background also isn't that great. I gotta paint the backgrounds here. But we essentially have three key reasons, okay? One of them we kind of already spoke about, which is encryption, and the way that we do that is via MTLS. This is essentially your client server level encryption, okay? But that's just one piece of it. And a lot of people, I think, like when they're thinking about a service mesh, they're thinking a lot about this piece. But in my opinion, at least, it's important, don't get me wrong, right? Like we want to ensure that this traffic is encrypted. But that depends on your application. Is your application in a place that it can have encrypted traffic going back and forth? Because again, remember, like when we started this video, the whole idea around a service mesh, which is encryption and network observability and traffic routing, this isn't a new thing. This is a new thing in the realm of Kubernetes, but like we've always had this. So like for example, let's say I have a Go app, I can use I think it's like crypto slash, I think it's the cryptography package. I'm probably butchering this name, but there's a package that you can encrypt, via TLS, right? Like you can encrypt service-to-service traffic just in, without Kubernetes and without a service mesh and all that. And a lot of languages have some type of like cryptography or TLS library or package or module, whatever you like to call it, to ensure that you can encrypt that traffic. But can your application do it? Like, is it readily available to be able to encrypt traffic and accept encrypted traffic? Now, the key thing with the service mesh here, I'm kind of going on a tangent, apologies, but I think this is important. The thing with a service mesh is, let's say I use that, a TLS related package or library or module. I have to write that code into my application stack, okay? So whatever you're using, whether you're building out apps in Rust or in Python or in Go or whatever, if I want to implement that TLS piece, I have to do it via the application, right? Like I have to put that code within the application stack. Whereas with a service mesh, it reminds me a lot of like a program that's sitting on top of a kernel. Great example is like eBPF, right? Like the whole great idea around eBPF is I don't have to modify any kernel code. Okay, I can just put this program on top of it and manage my traffic. I can now manage my traffic like that I would use with IP tables. Instead, I can use eBPF for those rules. And it's a program that sits again on top of the kernel versus implementing kernel level code. So service mesh reminds me a lot of that, because with a service mesh, it is sitting on top of your application. You don't have to like change any application code or anything like that to be able to get all these features. So you get things like MTLS, service-to-service encryption, without having to implement any type of TLS library. Now, a couple of other things you get network observability, okay? So you get to understand, this service A to service B is having some latency. What's going on here? And then the other thing that you get is network traffic rules, okay? So what does that mean? Well, I think a good example here, especially in like the DevOps and platform engineering cloud realm, is, let's say I have some type of canary deployment, okay? And what that pretty much means is, I have a subset of users still on the old version of the application and a subset of users on the new version of the application. I can take, let's say version 1 and, version 2, and I can use network traffic rules and HTTP rules to essentially set like the background weight to say, 20% is going here and 80%, is going here. So I would say again, like the MTLS piece is very important, encrypting, that traffic, as long as your application is able to accept incoming encrypted traffic. But the network observability piece to actually understand the performance of your underlying services and the traffic routing, those are the two biggest pieces in my opinion. So hopefully this helps. We went over quite a lot. The first thing that we kind of touched on was what a service actually is, because the whole idea of a service and what service mesh provides you isn't anything new from like a software engineering perspective. This is stuff that we've had for years, but service mesh implements it in a new way in Kubernetes. The next piece we talked about was why we would want to use a service mesh for MTLS level encryption, because the Kubernetes network is very flat. And then we talked about the three key pieces, which is MTLS, network observability, and the overall traffic management, traffic routing features within a service mesh, okay? And we touched on a little bit about the ingress piece, and that's probably gonna be a separate video because, you have traffic coming into the cluster, and then you have traffic within the cluster, east-west versus north-south, right? So probably a separate video. But nonetheless, thank you so much for watching. Really appreciate it, and hopefully this helped you out.